All right, thanks for joining me. We're going to go through as quickly and as efficiently, hopefully, as we can. You should have a practice sheet where you can take some notes based upon what I'm saying and practice and look at some of the different ways that we're going to do some graphing. I'm going to try to hit all the different things that we should be able to see with graphing. And all that the graphing is doing is just kind of making a picture of the motion that something has. And if you've worked on your Gizmo, then you've already been experienced with this. And so hopefully this will make a whole lot more sense. So we're just going to be looking at graphs about motion. We're going to try to interpret the motion from the graph and be able to talk about the characteristics of the motion from looking at the graph. We've got two different types of graphs we're going to look at. So the first one is a distance time graph. We know it's a distance time graph because it's labeled a distance. Okay, so all the graphs we're going to look at are going to have time across the bottom. What's going to be different about them is what's on the y-axis. The y-axis tells us what we're looking at. So if we see distance on the y-axis, this is a picture of something changing its distance. That's it. So we're talking about where is it? This is a graph of where is something. All right. So anytime from the next week or two, you see these graphs, you look at the y-axis first. That tells you what is changing. So anytime the line goes up and down, whatever is labeled on the y-axis is what is changing. So in this one, distance is labeled, so the distance is changing. All right, so something is moving. This doesn't mean something's going up. This doesn't mean something's going down. It just simply means something is moving from one place to another. So at the very bottom of our graph was going to be our 0. This is where something would start. And as we move up, it's moving away. Okay, so they help us to see motion and be able to make some comparisons and make things a little bit easy to understand. So by the time we're done, hopefully you can interpret each of these 4 lines pretty easily as to what the motion would be for that object. All right. The other thing we can interpret from the line is kind of the rate or how fast or how much time it is taking for something to change distance, because distance and time relate to speed. So these pictures also don't just show us where something is, but they're also showing us how fast something is moving. So I want you to take a moment for this slide and the next slide to be just kind of sketch it out and make a graph. So you probably want to pause the video so that you can look at this. We're going to move to the next slide and probably pause it there. So try to, in the box you have, go ahead and set this graph up. Take a pause. Right. And then if you were to plot out this data from 0 to 80, the line's kind of already drawn for you here, but we should end up having a straight line. So again, pause the video so that you can kind of graph this out. And once we have this data, you should be able to just kind of describe what's going on. So time is passing and the object is moving, and it's moving 10 meters every second. It's getting 10 meters away from the starting line. So this would be constant motion. If you're moving 10 meters every second, you're not speeding up, you're not slowing down, you're walking at a constant pace. And that kind of relates to what the line looks like on this, because this is a straight line. There's no bends or curves in it. And when we don't have bends and curves, that's telling us that something is moving at a constant speed and that speed is not changing. Okay, so again, your graph should kind of look like this. If you need to pause and finish it up, do so. So as I said just a moment ago, this straight line tells us that something is at a constant speed. Right. And when I say a straight line, I don't necessarily mean a flat line. It just has to be straight. So it could be straight going up, it could be straight going down. But when we see that on a distance time graph, that is telling us that the speed of the object is staying constant. It's not increasing and it's not decreasing. So if the slope stays constant, the speed stays constant. And again, we could calculate the speed using the data that's on here, because again, I'll talk about this in just a moment. Speed is distance divided by time. So we could take any 2 points on this line and figure out the distance and time change. And if we know the distance and time change, we can figure out the speed. So a couple of things to point out. If you have a flat line like this, that's completely straight, but it's also flat, this is an object, for example, in this picture, this object is staying at 40 kilometers. And if it's staying at 40 kilometers, then it's not moving. A flat line on this graph is indicating that there's no motion at all. The object's at rest because we're not going forward, we're not going backward. So time is changing, but the distance is staying the same. So flat line equals no motion on this graph, not the next one we're going to look at. So if we put all that together, we can kind of describe the motion of what's happening. So if we have first of all, this is a distance graph like we've been looking at, and it's time. So time is passing. Whether the line goes up, down, or stays flat tells us about something's motion. So this first segment, the line is going up, so something is moving forward. The second segment is staying flat, so someone is, in this case, we're not moving. And the third segment is also going up, which means the distance is increasing, which again just means that something is moving. So that's kind of how we would interpret the motion of this graph. With this graph, it looks a little bit different. So the line, we have a line going up and we have a line going down. And so if I go up, this is something moving forward, and then this is something moving back to where it began. So because this indicates a direction, this is velocity. Because again, velocity is speed in a specific direction. As I mentioned, we can determine speed using the graph that's on here because we have distance divided by time. So A is moving away from the starting point, B is moving back towards the starting point. And so because they're changing direction, we're changing our velocity. One would be a positive velocity and the other one would be a negative velocity. If we wanted to calculate the velocity on each one, we would just look at the line segment. We could use the starting and end points of this line to determine how much time did it take and how much distance was it. Because again, velocity is distance divided by time. If we measure this, it's approximately 2, looks like it's a little bit above it, but it's approximately 2 meters, or excuse me, 2 kilometers, and it took 30 minutes to do that. So we could divide that, 2 divided by 30, and that would give us our velocity. Same thing for B, we're going from 2 back to 0 in terms of how high the graph is. So that would be -2. And it still also takes 30 minutes. So we could calculate the velocity here is -2 change in distance, 30 change in time, and put that together. That's our speed or velocity. Okay, if we look at this one, if we want to describe the motion completely, if we want to do time traveled, distance traveled, and velocity. So first of all, what's happening is someone is moving away from where they started, someone stays still, they're not moving, and then someone returns back to the beginning. So this first segment, it takes 20 minutes because if we change right here, we'll go down and look, that's about 20 minutes. This next segment starts at 20 and ends at 40, so that's another 20-minute segment. And this last one starts at 40 and ends at 50, so this is a 10-minute segment. Now, in terms of distance, we look at the up and down. This one starts at 0 and it ends at 1.5. So we're looking at the up and down. So that's a 1.5 distance traveled. The second segment is flat, so it doesn't travel any distance. And the third one goes from 1.5 back to 0. So that's a -1.5. If we put all that together to do velocity, this first segment goes up 1.5 and it goes over 20. So I would do 1.5 divided by 20, and that would give me my velocity. The second segment is 0 divided by 20. So that would be 0 because we're not moving. And then this last one, again, distance is -1.5, and I would divide that by the time, which is 10. So my speed here, or my velocity here, would be -1.5 divided by 10. If there's a kind of a curve on the graph, that means that our speed is not constant. And if our speed is not constant, then we're either speeding up or slowing down. So in this graph right here, the distance graph has a little bit of a curve to it. So that tells us that we are speeding up. The more it curves, the more we're speeding up. So that's one of the things that we can indicate with this. So the steeper the incline, the faster the acceleration. That's kind of a new word for us right now, but acceleration is basically speeding up or slowing down. We're changing speeds. So if we put all that together and look at these graphs, this yellow line would be something that's at constant speed. This purplish red line is also at a constant speed, but the yellow line would be something that's going faster because it's got a greater slope. In other words, it's changing distance in less time. This reddish one is changing distance, but it takes more time. This purple one is something's moving forward, but because it's got a curve to it, it means that it's speeding up and it's getting faster and faster. And then this green one, something is moving at a constant speed and then it stops. And then this, when it goes down like this, again, all that means is it is turning around and moving back to where it started from. All right. So a different kind of graph is a velocity time graph. So if you glance at this, you may think it's the same one. The only difference is that on the y-axis, we don't have distance anymore. We've got velocity. So again, velocity is a measure of how fast the object is going, basically. And so the up and down motion on the graph is telling us how fast is it going. If the line goes up, that means it's going faster. So that means it's speeding up. If the line goes down, it means that it's slowing down. It's not going back to where it started from in this case, because it's not a distance graph, it's a velocity graph. So up is faster, down is slower. That's what the up and down on this graph ends up telling us. Okay, so if we look at each of the three lines on this graph, we want to interpret what's happening with this. So again, acceleration is a change in the velocity. That's the word we'll start using. That's kind of, we're going to move on to acceleration, because if we change our speed, that's what we're doing. All right, so we're going to look at each of these three lines and just say what's going on with each one of them. So this flat line, now in the previous one, flat line meant it's not moving. That's not the case here, because this flat line is on 10 and it's a 10 velocity. So that means that something is moving, but something's not changing how it's moving. So if the line stays flat on the 10, that means that it's continuing to go 10 meters per second, which means it's moving forward at a constant speed. If you put your car on cruise control at 50 miles an hour and you graphed it out on velocity, it would look like this. Now on the previous graph, it would go up like this, because we're changing our distance. Because if you have a constant velocity, you're moving. So if it was a distance graph, it would look like this. But if you're going at constant speed on a velocity graph, it's going to look like this. So that's what the red line means on this one. If we have the green line and it's going up, again, think about what's going. What is going up? The velocity is going up. What does it mean if the velocity goes up? That means you're speeding up. So we're accelerating. So the slope on this line, a change in velocity over a change in time, ends up telling us the slope. All right, so excuse me. What this line is showing us is that we're going 5 meters per second, we're going 10 meters per second, we're going 15 meters per second, we're going 20 meters per second. We are getting faster. And also, the steeper the slope, the more it's slanted, the more acceleration we're going to have. So again, acceleration is our change in speed. Like our other one, if the line curves, that means our acceleration is increasing. Not only are we getting faster, but we're getting faster. So we're speeding up, and we're speeding up more and more and more. We don't really see this happening a whole lot, because usually when we speed up, our greatest acceleration, like in a car, would be at the very beginning. So this doesn't necessarily mean we're just getting faster. It also means we're accelerating more as well. Kind of a weird graph. We usually don't really see that. So if I were to describe the graph, this graph right here, again, what am I looking at? I'm looking at how fast something is going. So at the beginning, this thing it's moving, but it's also speeding up. And then it's actually speeding up more. And then it's even speeding up more. So in other words, its velocity is increasing at a greater rate. Now, it comes to a flat part. This doesn't mean it stops. This means that its velocity is 40 meters per second during this time. So it's at a constant speed. And then at 60 seconds, its speed goes up, which again means it accelerates. You can't go wrong by continuing to repeat whatever is on the y-axis when you're interpreting this. So if you see the line go up, whatever is over here goes up. If it's a velocity graph, the velocity is going up. If it's a distance graph, just your distance is what's going up. All right, so these are kind of the three main types of graphs or types of lines we would see on here. And we should be able to do that. We should be able to interpret our object's motion and speed. We should be able to describe the characteristics. You should have been able to complete all the blank items on your handout that went along with this. If not, you should probably go back and rewind and see what you might be able to answer, and then do some practice with what you've been provided to kind of make sure that you know what's going on with this.